Hello everyone and welcome to this demonstration of Lattix with JAMA. My name is Neil Langmead. Today I'm going to show you how these two tools integrate. Firstly, we have JAMA, which is a lifecycle solution for managing requirements, and we will show the integration with our Lattix product, which manages dependencies, helps to analyze traceability and find gaps. And together we'll see how these solutions work, particularly for functional safety applications, and how using dependency structure matrices can help find those traceability gaps and improve safety and security outcomes. So first of all, just to give you a quick tour of JAMA itself, this is the default project that comes with JAMA. It's a standard example of their automotive safety and security critical software sample set. And what you see here firstly is what we call the TIM, the Traceability Information Model. As you can see, it's a small diagram, so I'll just try and make that a little bit larger. What you can see is a number of relationships between different domains. We start from an item definition, which is common in a functional safety standard such as ISO 26262, and we derive and we link to certain safety goals, functional safety requirements, technical safety requirements, cybersecurity goals, safety goals, system requirements, and software requirements, all the way down to test cases. And the verification of those test cases goes all the way back to the FSRs and the TSRs, which they are verifying. So what you can see from this traceability model is that everything is connected. You can go upstream or downstream, the idea being that anywhere you are in the model, you should be able to go upstream and downstream, depending on which direction you need to go for traceability. It's also clear, hopefully, that there should not be anything that's disconnected, that there shouldn't be anything that's not connected to the rest of the system, i.e. what we call an orphan element, an orphan requirement, an orphan test case that's not connected to the rest of the model. And in this system, you can see there's data. For example, in the safety domain, we have HARA, FMEA, we have stakeholder requirements, the item definition, and you can see all of these things in this simple template JAMA model. So the first thing I'm going to do is just show how that looks like in Lattix and the first steps to connect Lattix to JAMA. So I'm going to create a new project, and in the new project dialog, you'll see we have a module type called JAMA. So make sure that is selected, and I'm just going to call this the automotive standard demo, and I'm going to choose JAMA connection here to connect Lattix to the JAMA cloud instance. So I put the URL for my, in this case, my CodeClinic partner instance. Here's my username. I'm going to type my password now. And you'll see, assuming those username and password credentials are correct, that I have access to all of those projects that I've defined in JAMA. So I'm going to choose the automotive system safety and security critical sample set that I was just looking at, and I'm going to click OK, and that connection is now going to be established when I create the project. So I'm not expecting to see much in the dependency structure matrix because this is a sample project provided by JAMA with largely templated information, but this will give you an idea of how we connect firstly the two tools and what kind of data we pull down and visualize from JAMA. It's difficult to see immediately from JAMA which relationships, which domains are linked to each other. Sometimes you can actually see that using the relationship viewer here, and you can see in this case, for example, the data communication layer in this template has an upstream traceability to the detect crash, and it has downstream traceability to airbags deployed and collision due in terms of the hazard analysis and cybersecurity damage scenario. So we see those relationships. What we give you extra in the Lattix integration is the entire visibility of all of the connections between the different domains. So that connection has now finished, and I can click on the new dependency structure matrix, and I can immediately visualize exactly what we've just seen in JAMA. What we first of all notice is that we've picked up from the system development, we have these relationships, and you can view the information browser here, and you can start to interact with the relationships that we've deduced from the JAMA API. Here you see we have 10 relationships from the system requirements going up to the stakeholder requirements. And if I expanded those, you can see that all 10 of those relationships are between the functional requirements and the stakeholder requirements. So there's no relationship, for example, between the cybersecurity requirements and the stakeholder domain, or from glossary, introduction, or the TSR domain up to the stakeholder requirements. Usually in a completed model, we would expect to see that. So we can actually set a rule here that says there must be a relationship, for example, between the TSRs and the stakeholder requirements. And this would be then your traceability model that you want to see completeness and consistency. And standards such as ASPICE in the automotive world, and also in the avionics world, DR178C and airworthiness related standards, they require completeness and consistency. We have to do the same thing. We have to do what we say we're going to do. We have to do it everywhere. So even in this domain, we can see if we opened up the relationship between the functional requirements and the stakeholder requirements, we see there is a higher strength of airbags on the stakeholder requirements, where we have 6 derived relationships. We have 4 relationships for the sensors. Again, if I expand that, now you can clearly start to see that gaps are emerging. For example, there is a relationship between airbag identification and linking to the stakeholder requirements, but there's nothing from the impact response, from the rear driver side passenger airbag relationship, and the rear passenger side airbag and the side driver airbag. So these are clear gaps in our traceability model. Again, we can put a rule that says that there must be a relationship between these domains. And now we have these rule violations, which are effectively traceability gaps coming out of our model. So that's how it works end to end. Some other interesting things that you might notice, that we have relationships from the system requirements to the software. Again, you can interrogate and investigate those derived relationships here, and also from the system requirements up to the electrical engineering domain. And if I opened up these relationships here between the system requirements and the concept definition, we see a strong traceability. But again, opening that up shows that that relationship only exists between the TSRs and the concept definition. And we can actually see in this case, we do have the completeness that we're looking for between everything in the technical safety requirements domain and the high-level concept definition. Okay, so that was just a simple example. What about a more complicated example? So let's go back to JAMA. I'm going to change project to a tractor fertilizer sprayer, which is a complete system that has a bunch of requirements. It has a bunch of test cases which verify those requirements. And it also has some cybersecurity requirements, test cases, and stakeholder requirements. And same kind of thing. We can actually start with the architecture. If I show you the architecture of this system, we have hopefully a picture showing the different layers of this communication bus on the tractor. And this is our high-level architecture, which we can also analyze in Lattix and look at the dependencies between these different modules. Most things in this particular project in JAMA link to that architectural design. So we have all our different domains, and looking at the stakeholder requirements, we can see some of those high-level domains. We have one here for data security and privacy, and selecting that one, you can see again the relationships downstream to a software requirement that the app shall establish secure communications. And we can take a look at that, and we can explore those relationships using the relationship editor in JAMA. So what this tells you is, let's say this requirement changed, then you know immediately that you have to consider the upstream effect of that change and the downstream impact of that change as well. For example, a change to this particular software requirement would mean that we are impacting the high-level requirement of data security and privacy. Also, we're impacting the HARA analysis, the architecture diagram perhaps, which we're depending on, the software requirement itself, and the test cases which verify that requirement. And you can see all of these different types of relationships here. So what I'm going to do is connect JAMA now to to this particular project, and we're going to call this the tractor project. And I'm going to again connect to the JAMA API in the instance. And I'm going to just select that project as well. And because this is of a certain size, this will take a few moments just to parse and for Lattix to obtain all of that information. So I'm just going to let that run. And here we have the dependency structure matrix that is resulting from that connection to JAMA. And in much the same way that we've just looked at the standard automotive example, we can see those dependencies coming through now. So the first thing we notice is that, for example, we've picked out a test case, and only one of these test cases links to the software requirements domain. So again, a clear gap. We've established one test case can trace to the software requirements, but what about all these other test cases? And this would be an immediate finding in a functional safety review, that we have test cases, but they don't trace up to any software requirements. So I would do much the same thing I did with the example and set a must use rule here, that there must be a relationship between everything in the test case domain and everything in the requirements domain as well. What you also notice is that that traceability actually only goes to the app level here, and there is no traceability in the verification test cases to any other parts of the software requirement. So clear gaps as well. And here we see the different types of relationships that we've picked up from JAMA, including all of the cybersecurity relationships, the defects, the development tasks, the failure mode and effects analysis. All of these are selected in the API and then visualized. So a model which is slightly more complicated that I was working on with this JAMA data has a little bit more of the relationships populated. And you can see here that it's very easy to see where the gaps are, even at a high level, and not just the gaps, but also the way, for example, the technical safety requirements link to the unit tests and the way the TSRs are verified by these unit test cases. So you can actually explore these relationships, verified by and verifies in the other direction. And you can see there's a balanced relationship there, that each requirement has a test case which verifies that requirement. So in this case, we have reasonable traceability, but again, a whole suite of, in this case, unit tests, which don't map up to the software requirements domain. We've started that traceability, we've got some good results, but again, there are clear gaps that we see here. So I'm going to set that to be a must use again. And now you can see those gaps in the model. Similarly, you see the gaps here in the TSR domain, the technical safety requirements, linking up to the software requirements domain. And again, you can see you have some coverage of that from the TSR up to, in this case, the particular unit test that verifies that. I'll just collapse this, you can see it. But we don't have that coverage everywhere. Same for safety goals. So safety goals are satisfying functional safety requirements, hence the satisfy relationship here, and the HARA analysis here as well. Good coverage from the HARA domain to, for example, the technical safety requirements, but we don't have a relationship here from the HARA to the safety goal from this part of the HARA at least. And also there's a whole set of gaps from the HARA to the unit tests, which tells me that my hazard analysis is not being verified by a unit test, at least not explicitly. Now, part of my role then as a functional safety engineer would be to investigate and establish that link between the HARA domain and the unit tests and complete those gaps, and maybe ask some questions about why that relationship is not present. Also then at the integration testing level, we've got different types of testing levels, obviously. We have some relationships up here from the integration test domain, and you can see I have a nice coverage from integration testing level to the software requirement, with each one of these test cases verifying a particular software requirement listed here. And you can see which requirement is being verified. You can see that relationship, and you can see that the test case verifies the requirement in this way. So there you have it. That is Lattix and JAMA connected, visualizing the relationships, finding the gaps between all of the different domains, setting the rules for the traceability model that you have established in JAMA, and making sure that those are enforced. It's then also a simple matter to do an impact analysis in Lattix. So for example, if I go to a view with the source code as well, where I have what we call a multi-domain view. So I don't just have the requirements from JAMA, I also have the source code in here. This is where the model gets even richer. I can see from the code domain, for example, that I have some traceability gaps between the code and the tests up here. And if we pick our favorite source file that we often use and cite in this example, you can see I have, again, good traceability from this part of the source code, this part here up to the requirements. So this was our util funcs that we started off with in JAMA. We see that that is the implements relationship. And we see this one is the util funcs.cpp mitigating an FMEA risk here. And you can expand that FMEA and you can see utils leaking username and password data. That is mitigated by a function in the util funcs. And also you can see that this particular function is exposed by this Hara as well. You can also then see mapping to the people domain that Tom tested this function, Emma has tested this function, and Neil has implemented this function. So we see the people are affected by a particular function as well. Now when I do an impact analysis, it will show me every element in my JAMA model which is affected by a change to that component. Not just the source code, but everything across the requirements, Hara, FMEA, and other domains. So let me show you how to do that. I'm going to mark this function as being changed, and I'm going to run an impact report on that changed function. And I'm going to just do that here and up to the member level to show the complete expanded transitive closure of a change to that element. And you can see there are 3 levels of impact when I change that particular function. So the first level of impact, you see firstly down here all the source code artifacts that are connected to that particular function. But now at the top, you also pick up the fact that this change impacts Tom, Emma, and myself, and it impacts this requirement, which is implementing, and it also affects this part of the Hara. So you have the complete effect of a change on any element in the JAMA model, in the traceability information model, and the source code itself. What is absolutely incredible is that that information is also then available to the Lattix MCP AI server. So here I am now in VSCode, looking at this same function that we've just looked at in the architecture. We see that this function has a critical cybersecurity vulnerability. I have a hard-coded password, which is a CERT 130 and a CWE 259 issue. And usually the question when we find a security vulnerability like this is, what do we do about it? What's the impact of this vulnerability on the whole system? And that is, again, something that we can explore in VSCode or the Lattix Impact Explorer. The interesting thing is, because we have the VSCode now and the Lattix MCP server, which I can see here, if I just list the MCP servers, we see that the Lattix model here is running. That means we can ask the AI what architectural rule violations there are, what traceability gaps there are, and what the impact of a change to a JAMA requirement actually is across the whole system. Not only that, we see that in VSCode. So if I go to this function and I use the Lattix Impact Explorer, you can see I have the upstream and downstream traceability. This function is called by this function, it's called by this function. But here also, we have the requirement change coming from the mitigation of the FMEA. And now I know that this function impacts that part of the FMEA. If I scroll down, I can also see that this is impacting the Hara analysis. It's because this particular function is exposed by that Hara. And I can see that I myself am impacted by a change to this function. I basically have the whole dependencies across multiple domains in the hands of the developer, and I can explore that impact to my heart's content and proactively inform other team members that this function is changing, and I know exactly which parts of my system are affected by this change through this data. Then I could also use my AI Copilot, or in this case GitHub Copilot MCP, talking to the Lattix MCP and say what requirements are affected by this function, by a change in utilfuncs.cpp. And again, the Copilot will tell me that, and it will tell me the Lattix architecture rules that can be improved, and will then go on to suggest code changes to fix these issues that Lattix has found. And now you can see the actual requirements chain as well, coming from the conversation with the AI and the proposed changes that the, in this case, Copilot is actually proposing. So here you see it end to end. A requirement in JAMA is defined. The model is created, connecting JAMA and the source code together with Lattix as the source of truth, connected to the MCP server, bringing all that together in VSCode in this way to perform the impact analysis of a requirements change on the system across all parts of the safety domain, and proposing changes as a result if we find a vulnerability or we need to update that requirement. We also then have the ability to connect that to something like Claude Code, and the AI model is actually then available not just in VS Code, but we can actually talk to the model through VS Code, and we can actually define those requirements, explore those relationships, and see the functional safety domain dependency kinds that are being explored as a result of that. We could then also, for example, use the Python API with Lattix to produce a custom report showing the traceability chain, the traceability gaps, and the different types of relationships that have been reported. So in this case, I have a list of safety goals, my FSRs, and my TSRs that I've been talking to Claude with, and all of that conversation then can also be packaged into a Claude skill, for example, or can be used with a local AI model as well. So that concludes this example of an integration between JAMA and Lattix. Thank you for listening. I look forward to hearing any questions you may have. Thank you. Bye-bye.